That's it. Hi, everyone. I won't take too long because the dinner is approaching. So this talk is going to be on deserialization bug. So if you are a pen tester, this talk will give you a good trick that will probably be able to reuse this year at least. And if you're a sysadmin, this will expose you a problem that is getting more popular. So yeah, so it's a practical talk, but a technical one. So who am I? Before starting the talk, I'm a researcher at GoSecure. So basically, I'm doing analyzing vulnerabilities and trying to find new ones on a popular software. I'm also doing various tools to help pen tester and other security analysts. Some of the tools I do find security bug, as Pierre-David mentioned. So it's a statistic analysis tool. I also do one for .NET and other burp extension for helping pen test task. I'm a volunteer for NorthSec for a few years. I'm doing challenges, and it's the second time I'm giving a conference here. So now getting into the subject. So why we are here? So what do all these applications have in common? So late at the last year, all those applications were vulnerable to the same vulnerability class. So it's the same pattern, not exactly the same exploitation, but it's really the same vulnerability class. And all those are Java applications. But we'll see, I'll try to highlight also the design principle and the design problem related to this flaw that also apply to other language and other library. So the common thing is that they all use serialization functionality that are accessible remotely. So how I will divide this talk. So first, we're going to go through the basics. So just explain what is deserialization to make sure you understand how serialization is used properly. So what's the real use case? Then we'll go into exploitation scenario to see how we can use alternate behavior and unexpected behavior based on this functionality. I'll also give example of other language just to show that there are small differences, but it's same principle that will apply. So what is deserialization? So I'll give a basic overview. So first, what is deserialization? It's when you transform data and you put it in a format that is ready to be transferred or stored. So why do we do this? We do this transformation either to persist a state, so for example, to do storage of a state of the application, a session, or anything. We can do caching with serialization. Also, communication between process, if we need to restore something in another process. And what will be the most interesting case will be network communication, because if we're talking about client-server communication, that's much more potential for security, for pen tester to get remote code execution than when it's all local communication. So that will be the main focus of our different attacks. So how does serialization work? I have a visual representation. So we have one application running. In this case, it's a client application. We have various objects in memory. And we cannot just copy the memory representation because object will have tons of reference of caching property that we don't necessarily need to transfer. That's why we're doing a transformation, and we'll extract some of the field potentially. So then we will create we'll serialize to an object. So it will be a format. So here we're going to talk about native serialization, but it's same as JSON, XML, protobuf, beancode. All those can be considered serialization format, but they will have difference, obviously, in their representation. And when the other application will receive this format, it will be able to restore this state and reconstruct the object out of it. So I have listed a couple of formats. But what's the main difference between native serialization in Java and, for example, JSON? So the main difference is that Java native serialization, you can add custom behavior to objects that are being deserialized. In JSON, it's static and info, so you can list property, but you cannot add custom behavior when deserialization occurs. At least not in most popular libs. So I have a couple of examples. Just to give you an example, so here, optionally, for serializable object, we can, in Java, create a read object method, and this read object method will be called when the object gets deserialized. So if it's a communication over a network, when the server will receive the object, if it's a custom a serializable object with a read object, this will be executed when it's deserialized. I have another example here that is doing other thing. But in general, it can be more complex calling other classes. These are really basic example. And one thing to remember is, from a design point of view, from a security perspective, I mean, as soon as you have custom behavior that library are introducing, for the attacker, it's an additional entry point. So contrary to static data like JSON, if I know that I can instantiate any class of your application and trigger those read objects, maybe I will be able to instantiate classes that are not expected to be called. So then those read object behavior could be triggered in an unexpected way. And one thing to mention, like in the example on the left, the object state will be restored, so the property will be filled, and then some execution will occur. So then the attacker has an interesting entry point because he'll be able to initialize the object as he wants, and then the behavior will be executed. So this introduces much more possibilities. So in the code, we'll see just an example of Java deserialization. So if the server receive a payload, it will do read object to deserialize the object. So internally, what it will do, in the byte stream, it will find the class name. Based on this, it will load the class if it's not already loaded. It will instantiate a class. No constructor is called, so by default, no method is called. And it's only if read object method are implemented that they will be called. And the common cast that we see, this is not something that happened prior those steps. So the execution of the read object method will happen even if the object is not a command. So it will trigger in the end a cast exception, but this does not stop an attacker from sending any type that is available in the application. So there are no assertion that, in this case, command object will be sent to the server. It can be any object. So we'll look at one example that was the most common one to the application we mentioned previously. So we'll look at command collection. So we need two ingredients to have a vulnerable application. First, we need deserialization. If you're not doing deserialization, your application is not vulnerable for sure. So if you have proprietary application, I'm going to show you in the end a tool that will be able to scan your application and find if you're using deserialization somewhere in your application, potentially in legacy functionality. And the other ingredient that is needed to have a successful exploitation is have for serializable class. And those serializable class, we'll call them gadget. These are class that are serializable with interesting read object method. And when triggered, we can do unexpected behavior that will lead to remote code execution. So the main design flaw is you shouldn't do deserialization and accept any class, any type of object on your class path, because you'll have so many libraries that you don't have looked at that could create a bad behavior. So this is one of the popular gadgets that all the application I mentioned prior had in their class path. So those are classed on the right from a lib command collection from Apache. And I won't go into the detail of how the gadget works because I want to stay high level to just to make sure you understand the design principle that is the design flow. But in the end, those classes can lead to remote code execution. And the interesting to notice is that some of the class, the chain transformer, are not classed with the read object method. And the way they are triggered is that they are we're using an invocation handler, and invocation handler is serializable object that is another entry point. So it's not only serializable class that are interesting to attack, because invocation handler in Java is going to be a combination of invocation handler and a proxy. So the way it works, it's like in ECMAScript. So if you want to do mocking on object, you can replace, if you, instead of calling class test, you could mock a class that will likely implement test, but instead all the call will be redirected to a proxy, the opposite, to an invocation handler. So the idea is that proxy are serializable, so in your gadget you will put an instance of a proxy, and it will reference to an invocation handler that you'll be your interesting entry point. So all invocation handler in the class path of the application can be triggered by an attacker. And it was the case of command collection. They were using an invocation handler from the GDK, but in the end it was calling command collection classes. So I will do a demo of a tool that you could use in a pen test that is wrapping tons of gadgets, so you don't have to build yourself all the chain of that I presented previously. Okay, so this demo, I've chosen JBoss because visually it's more easy to understand, because most of the vulnerable software were vulnerable over a remote admin client, so it was all command line client, but this one, it's over HTTP, so it will be more visual and easier to understand. So we have all the version of JBoss here, and the interesting endpoint is invoker. I'll just zoom a bit. At this URL, invoker, JMX, invoker servlet, and this endpoint receive a serialized object. So if we're using the application or the admin panel and we see serialized object in Burp proxy, for example, then we know we have a potential to replace those serialized objects with our malicious gadget. And that's what we'll just do. So I'll just zoom out. So the tool I'll be demoing is YSO serial. So I think it's visible. So it's pretty easy to use. When you enter no argument, it will list you all the gadgets available. So the idea is that gadget will only work if the needed classes are on the class path. So if, for example, you have the command collection library on the class path of the vulnerable application, it will work. But if it's not the case, you might need to rely on another variation. And the arguments are quite easy to set up. So the first argument will be the payload. So in this case, we'll use command collection 1. And the second argument will be the command will execute. So in this case, I'll just run calculator, but you could replace this to some wget to our reverse shell and then execute it for having a reverse shell on the server. So I'll just do this. So the output will be a serialized object. We can, if needed, we can encode it into base 64. The output is just the payload. But in our case, we'll just save it to a file, to NorthSec.bin. Just to show back the command. So the only two arguments were needed was the which gadget we're going to use, and then the command being execute. So this, you replace this with your reverse shell. And where I'm saving it to NorthSec.bin. So on the left, I have burp in repeater. So I will be sending an HTTP request to the vulnerable endpoint. And if I send nothing, I will get deserialization error, telling me the empty value, I get an error. Instead, I will load from the file I've just saved, the NorthSec.bin. Oops. And this is the serialized gadget. So, and as soon as I will send it, then I get execution because my server is running on the same machine. So this is just a visual confirmation. And the, yeah. Okay. It's actually a really writable exploit. So if you see in your assessment all vulnerable, all the GBoss, WebSphere, all those Java container, a lot of them add a remote API like this. So that's for identifying, exploiting actually with gadget those vulnerable services. So the basic methodology is you need to first find serialized object going through your proxy. Sometimes it will be in Wireshark if it's not HTTP request. First, then the second step will be to generate a gadget. In this case, with WireSocial, we will able to generate one for command collection. Then we replace the initial object by it, and then we just replay the request or continue with the protocol. If it doesn't work, you can repeat the same thing with different gadgets. So it's just trial and error. Since if you're doing a black box test, you won't know for sure what are available classes on the remote application, but you can just try one after the other. If it doesn't work, it might be a specific protocol. Sometimes if they read ints or other primitive type prior reading the object, you'll need to just follow the sequence of the protocol until a read object is done, and you'll be able to do the same thing. So that's a little detail. And if it doesn't work, it might be that it's not vulnerable, so they are whitelisting the class that could be deserialized, or there could be a blacklist in place. So that's the demo I just did. So that's from an attacker point of view, or if you're doing pen test, that's what you would do, black box. But what if you have a proprietary application in Java, for example, and you want to know, am I vulnerable to this? And because you could have so many endpoints, sometimes you don't remember the legacy one. I'll do an example of how you can scan your application, or even proprietary application that you don't have the source code from. So what you'll look for is two things, the two ingredients I mentioned prior. So the deserialization operation, so this is the design flaw, and potentially the gadget to exploit. So if you are testing an application and you are able to download a trial or download the application, you could do a scanning and potentially find the interesting endpoint that are exposed that do deserialization. So this will give you some hints. And also, if the gadgets are not part of the known, you might need to build a custom payload from this. So the demo I'll do is with find security bugs. This is the static analysis tool I'm maintaining. So in this case, I'll just analyze the same application as previously. So In this case, it will be gbus. But if you have an application, you could do the same thing. So find security bugs, the command line, how it works, you specify directly a jar. But if you want to scan completely all your application, you could extract all the list of jar and then passing it to the tool, and it will scan everything. So in this case, gbus, it's around 2,000 meg of binary jar file. So what I've done, I've created a list that contains all the jar, and I will pass this the content of this file to the tool. So the command just looks like this. Oops. Okay, so the command is in detail is not that interesting, but I will be analyzing all the jar of gbus, and I will be creating a report out of it. So this could take a couple of minutes, so I have already a report produced. And one little detail to mention is that I don't have the source code of gbus right now, so it's only scanning the binary format. So this is interesting because you'll have a full coverage of the class available, and you'll be able to reproduce this on a proprietary application also. So I'll let this scan, but I have already the result. So we're looking for two types of things. First, the deserialization part. So as an attacker, if you're looking at a big application, you want to know where in the application deserialization occurs. So you'll have obviously a couple of false positives because, as I mentioned previously, serialization is used for multiple use cases, and it's not always remotely accessible. But here in gbus, we can quickly see by the package name that we'll find some remoting packages. So this is a remoting API, so most likely accessible from remote. And other REST-easy is also something accessible for REST API, so could have a potential. So we could analyze those. We have a reference to in which method and in which class the deserialization occurs, so we can review with a disassembler or decompiler. Now that we know that it's vulnerable to deserialization, we need to find gadgets. So we could try the gadget from YSOCL, but if we wouldn't have a known one that work, in the next version of Find Security Bugs, there will be a gadget finder for based on multiple heuristics. So basically, we don't want to list all the serializable class in the application because there would be a couple of thousand, possibly. So those are all case where deserialization is serializable class with risky operation being done, sometimes reflection or other behavior. Also, invocation handler are also identified as a variant of those. And the third occurrence that it will find is actually the vulnerable gadget that was found in a common collection. So with this tool, if you want to do research and find your own gadget, if you're stuck because because currently library are proactively patching those, so they add switch to make them not serializable remotely, or add switch. So the gadgets are still there, but not exploitable. So we need to find new ones. So if you want to find new ones, that's one way that could help you, because it will highlight you some interesting class instead of looking at all the code of all the library in your application. So that's from a defense perspective. If you have you're maintaining a web application in Java, you could use also the plugin in your IDE to do the scanning also. And I'll quickly go to the other language. So that's just to highlight that this is a design flaw that applies to multiple type of libraries. So it's not just native serialization in Java. As soon as you see custom feature that occur during parsing, It's something that we have saw also on other library in other language that they decide to add custom behavior that could be triggered by inserting a specific keyword or specific part in XML, for example. So any library that has custom behavior to deserialization could lead potentially to unexpected behavior and remote code execution potentially. So we'll look at the PHP case. So PHP unserialized method, there's no possibility to whitelist the class that you want to unserialize. So really, if you're doing unserialized PHP, which is you should never do, you're open to all the class that are loaded from your file. So anything that you have include will be accessible and will be able to be deserialized. This will include, obviously, also all the class of PHP API. And the interesting trigger here, there's no read method like in Java, but all the magic method can be triggered accidentally. That means that if you're deserializing an object that an attacker sends, it will also call the destruct method when the script will finish execute. So then you could have also a chain of execution that would lead to remote code execution. In general, the chain will be quite complex. It will be a chain across multiple objects. But here I have a small example that is easier to understand. So this is taken from Aclu CTF, and the challenge was there was an unserialized operation that was being done, and you had also access to source code. So you had a couple of PHP files also with the application, and one of the class SQLDB was having a deconstruct method, a destruct method, and each time the SQLDB was being closed, it was calling SQL close and then create log, and the create log was doing SQL queries. So from the developer perspective, it didn't intend that this method would be called remotely. It's all variable coming from the local object, but the attacker, this class become an endpoint because I can call the destruct method with any state that I want of this object. So any field, I can put it in the state that I want. So in this case, the interesting part was the create log operation, and it was doing SQL query with sanitization. But sanitization, what it will do, it will, if you add a single quote, it will add a backslash and the proper escaping. But here the thing to notice is that the log table, the table, is not between quotes. And in this case, we don't need to add code, so we'll be able to do just a straight injection. So the way the gadget or the malicious payload will work is you serialize this class with the malicious value log table, and once it will execute, it will trigger the SQL injection. So that's for the example in PHP. In Python, it's also a bit different. There's a pickle, which is highly documented that you shouldn't use in remote API, but you'll find it not that often, but more often in CTF. And the interesting part is the reduce method. So like the read object method in Java, you can specify a custom reduce method, and this method will be called once objects are deserialized. And the main difference with Java is that you're not dealing with all the object. You can also even serialize this method in the object that you want. So you can also serialize code section with the object. So here we have a basic example. So call puck, calling call.exe, and the remote application doesn't even need to have this class in its application. We'll serialize this class, and the reduce method, as we can see, is doing the code that we want to execute. So in this case, it's creating a process. And in the xdump or the serialized version, we can see that the code of the reduce method is also bundled. So this is probably the most easy way to exploit serialization, because we don't need to, yes?
Don't you need some
Yeah, potentially, but yeah, but then you will need to use another API that is available. Yeah, that's something I'm not sure, but I will have to check. So the main difference to remember is that in the case of Pickle, the reduce method, the code is serialized with the object, so it's not just property and data. So solution. Instead of doing patch and doing whitelists, so for existing application, if you have a legacy Java application that are doing serialization, you could add a blacklist to reduce the risk of having known gadget being used as an exploitation vector. For a new application, you should simply choose a library that are not doing fancy behavior on deserialization, so using JSON, protobuf if you need a compact protocol. So that's something to remember at design, because afterward it will bite you as you have more problem to maintain it and patch for the different gadget. One of the projects you can use out of the box for Java is NorthSec. It will blacklist by default all the known gadget, but it's just a guacamole game until somebody find another gadget. So that's it. I'm done with my talk and my demo. So if you have any question, don't hesitate to ask them now or afterward.